my name is Mrs. Ellis. I teach 5th grade at Bluegrass Elementary. And this is Science 5th grade, Activity 2. Activities and handouts can be found under the Student Resources tab on the Knox County website. And show us what you learned and tweet at KCS Science. If this video is too hard to understand, there's some things you can do. Turn on closed captions if available. Adjust the playback speed to slow down the video. Consider watching short clips and then pause, listen, and watch again. Ask someone in your home to watch the video with you. Stop frequently and talk to your partner about what you heard and understood. So this is my grandson, Jonah, and I took him to the playground for the first time in February. And being the science teacher I am, I started looking around and thinking about motion, all the motion that was around me, and looking at the playground equipment. So I want you to think, what are some motions that we observe at the playground? Swings, you probably thought of swings. It goes back and forth and up and down. Merry-go-round, and the slide, which is down, and the seesaw, which goes up and down. So we are going to investigate patterns of motion. When you think of those things, you think of swing and the merry-go-round. It's a repeated motion, the same motion, like back and forth, like the swing, back and forth, and around and around. So our question is, can we look at patterns of motion to predict future motion? Our first activity is going to be observing motion. Our second activity, we're going to build a pendulum and conduct tests. And then we're going to have our conclusions. We're going to go back to that question and use evidence from our activities to answer it. Okay, activity 1, observe motion. And this is where you can take your handout out. Look at the picture below. Think about what you would see in a photo that was taken seconds later. Are forces balanced or unbalanced? Now remember, balanced forces, balance is same force on each side, net force, so it's not moving, and unbalanced means that the net force is different, so it is moving. So the little girl is swinging, and think about what's going to happen next if the photo is taken seconds later. And you see that there's an arrow going up and an arrow going back. Is there a pattern to this motion? A pattern of motion is a motion that occurs over and over. Describe the pattern below. So in your handout, you're going to describe the pattern below. And I'll give you a minute. Now we're going to fill in this table to observe motion. When we're observing, we're using our senses, we're using our eyes, mostly with this because we're describing it with describing words. So I put 1 in there, it's jump rope. So think about what you're doing when you're jump roping. How would you describe that to somebody? And I want you to think of 2 more motions, and I want you to describe them. So why would it be important to predict patterns in motion? So why are we even talking about this? Let's think about it in the real world, in jobs. Why would predicting patterns in motion be important? Think about engineers. What do you think this picture is? Crash test dummies? So think about cars. What would we need it for? Think about motion in cars. Maybe to make sure the car is safe, and they would need to predict patterns of motion to make sure that the car is safe. What about football helmets? Again, another safety. If they're playing football, you don't want them to get a concussion or brain damage, even worse. You want to have a good helmet. And we talked about the playground earlier, the equipment, who's constructing it and designing it, is it safe? And amusement parks. And there are so many more that I didn't even mention that you probably thought of. So it's important for us to predict patterns. Our second activity, we're going to measure data of patterns. So we've observed it. Now we're going to actually get data from it. So a pendulum is a weight on a string that hangs from a single point. It swings and creates a pattern of motion. So if you look at the picture, there's a fixed point, a wire, and then a bob, which is a weight at the end. This is a simple pendulum. And there are more complex ones. Now, what is a pendulum used for? We know that there's a pattern of motion because we can kind of see in the picture the arrows. Think about the older, like grandfather clocks. You've probably seen them in somebody's home. But it has that pendulum at the bottom. If you look, there's the bob, the weight at the bottom. And you can't really see the wire, but it's probably metal or something a little bit thicker. You also use pendulums, and you've heard of metronomes in music. It keeps the beat. And even earthquake seismographs to help see, I guess, how bad the earthquake is or the level. So it's used in many different things. So activity to measure data of patterns. We will conduct an investigation to record data and look for patterns to predict the pendulum's future motion. Now, here's a list of things you need to build a pendulum. Now, there's a couple things you can do. You can stop the video and go get the materials and build your own pendulum right now. Or we can together go through and use a pendulum I made and the videos I made, and we can go through that, and then later you can build a pendulum and kind of compare the data sets. If you're building your own pendulum, you can kind of look at these pictures to help you. If you look at your handout, it gives directions on how to build the pendulum. And it talks about how it needs to be 38 centimeters. So you have your ruler to measure it, but it has to be from the top of the loop to the paper clip. And of course you tie the paper clip. I have a picture of that. And then I have a picture at the end what it should look like. And I even have some video. So if you watch it first and you go back and make your own, you'll be sure to do it correctly. So we're going to continue. How many times do you think your pendulum will swing in 20 seconds? Before we even think about that, there's a couple things we need to think about. Being scientists, when we conduct tests, we need to have fair and accurate tests, not biased. So we need to agree on a couple things. Start the pendulum from the same height, which on your table, if you look at your handout, it's the release angle. And what qualifies as a swing, and how time will be kept. So I want you to look at your table where it says release angle. We are going to level it with the table. You can put level with table, or you can put 90 degrees. If you had a protractor and measured, it would be 90 degrees. And what qualifies as a swing? It has to swing back and then back to the starting point. So back and forth, just like a swing, one time. And you can use a timer to keep time. I have a little like kitchen timer, or you can even use your phone timer. So going back to, I want you to think, how many times do you think the pendulum will swing in 20 seconds? And just, kind of think of it in your mind, just predicting. Now this first one, the video, you can kind of see we have it on the table, and I'm holding it level with the table before I start it. And we're going to count, I'm going to count out loud, and you can too, for this first one. And this is our trial one. And remember, in our variables, we keep everything the same, and we only change one thing. But right now, we're just trying to get a starting point. So we're going to do 3 trials, the same thing. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 16 swings. So I'm going to write down 16 on my paper. You can go ahead and write down. Fill in the table. Okay, so this is trial 2. I'm going to count quietly now, and you can count out loud or you can do it quietly. Okay, so what did you get? I got 15 swings, so I'm going to put down 15 on my table. Okay, oh, hold on. Okay, now we're on trial 3. So again, I'm going to count quietly and you're going to count. Okay, so what did you get? I got 15. So I'm going to put it down on my table. And here's the table. So you should have your release angle already filled in, level with table or 90 degrees. The number of swings I have for my first trial, I have 16. My second trial, I have 15. And the third, I have 15. And then it has mean number of swings. Remember the mean, you add up the 3 trials and you divide by 3. So I'm going to give you a minute to do that. Okay, so I got 15.333, so I'm just going to take 15 because I added 16 plus 15 plus 15, and then I divided by 3. So the results in the table above will be the starting point for our investigation. We'll use it as a standard of comparing it to other results. What could we change in our pendulum system that might change the number of swings in 20 seconds? So far we have 16, 15, 15. It's about the same. What is a variable or one thing we can change? Anything that we change in a system that might affect the outcome is called a variable. So when scientists conduct experiments, it is important to only test one variable at a time. And if you look at your table, at the headings, we have like the trial, the length of the string, the time period, the number of pennies, the release angle, and the number of swings. You're only changing one thing at a time to test it. So this next experiment will test how mass affects the number of swings. We will change the mass by changing the number of pennies that are attached to the paper clip. Now we've already done 1 penny, and we've already done the mean for that. So we can fill in, oh, there's one more thing we need to do before we do that. So this experiment will test how mass affects the number of swings. We will change the mass by changing the number of pennies that are attached to the paper clip. So the independent variable is what we are changing. What are we changing? The dependent variable is what we are counting. What are we counting and looking for and filling in our table? So now we can go ahead and fill in trial 1 because we already know how many swings for 1 penny. So remember, my mean number of swings was 15, so I'm going to put 15. So now I'm going to put 2 pennies. There's 2 pennies in the paper clip, and we're going to count together. I'll count out loud as you count at home for this second trial because we already have 1 penny. We're doing 2 pennies. Okay, what did you get? I got 15. So go ahead and write it on your table. Now we're going to do 3 pennies. Okay, I got 16. What did you get? So based on the evidence that we've collected, how does the mass affect the number of swings of the pendulum? So we can look at 1 penny, 2 pennies, and 3 pennies. And we can look to see, is there some sort of pattern? Look at the table and compare the number of swings to the number of pennies. Using the pattern in your data, predict the number of swings that will result from a mass of 4 pennies. So we're going to do 4 pennies, but I want you to make a prediction first. Explain how you use the data to make your prediction. So how many swings do you think there will be with a mass of 4 pennies? Did the number of swings change due to the increase of pennies? So now we're going to test it, and then we're going to see how close we were to our predicted value. Okay, so how many swings did you get? How close was it to your predicted value? Conclusions. So if we wanted to continue our pendulum investigation, what are some other variables that we could test to see if it affects the number of swings? So if you look at the table, we tested mass. We had our beginning to compare it to, and then we did mass. What's something else that you could do? If you look at the table, we could do length of string. Would that change the number of swings? The release angle, remember we did 90 degrees or level with the table. Would that change it? I would really love if you continued this pendulum investigation and you found out. So now we're going to kind of wrap it up, wrap it up. We have observed patterns of motion by describing how they move. So we looked at the playground equipment and we're like, how did the swing move? How can we describe it in words? And the merry-go-round, and then you did a couple of your own. We used a pendulum to investigate how mass, changing the mass, affects the number of swings. Did it? And we looked at data for patterns to predict future motion. Remember we did the 1, 2, and 3 pennies, and then we had to predict about 4 pennies. So now you're going to fill out in your handout a claim, because we're going back to that question. So our question was, can looking at patterns of motion help us predict future patterns? So our claim is, patterns in motion can predict future patterns. And I want you to use evidence from the pendulum investigation. Thank you so much for joining me, and I really do hope that you continue with this pendulum investigation and you let us know what you learned and you tweet it out at KCS Science. Thanks again.